In this video, I'll explain how to perform the capacitor mod. I assume that you have read my posts that explain what this mod does and why it is needed. In case you have not, I will put links to these into the video description. To sum it up, this mod makes aerial neutral beam inputs consistently go into the intended direction. In Smash 4, it does the same and also makes empty pivots not change direction again after letting go of the stick. The capacitor mod is the only modification to achieve this without the risk of severe side effects, at least if done right. On these two controllers, these here, this mod has already been done, and I will show you its main side effect and how to work with that. So when we plug this controller here into the Wii, and then look at the in-game character, you will see that Fox walks towards the right on its own. So there is drifting. After plugging in, the stick always drifts to the right. By resetting with X, Y and start, you recalibrate the controller and stop the drifting. Now Fox will stay in a neutral position if I don't press anything on the controller. This resetting only needs to be done once after plugging in, so it will never suddenly start to drift mid-match unless you replug the controller. This controller right here does have snapback and has not been modified yet. I'll perform the entire process on it, but before that, let's go through the necessary tools. We will need a tri-ring screwdriver, a soldering iron or soldering station, a hot glue pistol, solder, a cutter or knife, a wire stripper, female jumper wires, and finally the main component that we need in this mod, a ceramic 1 microfarad capacitor. Its label says 105, I'm not sure if the camera will pick this up. Yeah, but 105 means 1 microfarad. First we turn on the soldering iron. Here I'll set to 420 degrees Celsius. And we also turn on our hot glue gun, so that both of them are ready to use on time, while we do the other modifications that are needed to prepare the controller. We open the controller by simply taking the 6 tri-ring screws out. Now we gently take out the rumble motor wires so that they don't get damaged. After that, we can remove the black rail, or here it's purple actually, usually it's black, by holding its 2 clips at the front . These here. Down and pushing them backwards. Then we slide the L and R digital input plates out from the rail, so that we only have this piece taken out. Why do we need to do this? If you look at the finished controller, you can see that we need some space, an additional space between the black rail and the PCB, so that we have room for the cables, for the female jumper wires, and the hot glue that keeps it in place. We take that space by shaving off a bit of the plastic with our cutter or knife. We do this here. This corresponds to this part here. So we take our knife, be careful to not cut your hand, and shave off a bit of the plastic. Then we prepare our female jumper wires by cutting both of them in half with our wire stripper tool. After that, we only need 2 of them for one controller, so we take one brown and one red one, and the other 2 we set aside for a different controller. And now we strip a few millimeters, about 3 millimeters, with our stripper tool, and we use the 3.5, I think this means 3.5 millimeters in thickness. We use this hole to strip it down. We do this for both wires. And afterwards we twirl the copper threads together and stabilize them with solder so that the individual threads don't stand off from the main branch and make contact to a different pin on the PCB, which would cause problems with misinputs and drifting even. Okay, after you've twirled them a bit, you just put them here, and by now our soldering iron is heated up, and we use the solder to put a bit of solder to the ends, just so that they have a light solder coating and don't that the threads stay together from the solder. Then we put the soldering iron away again for now. And now we can already take the PCB and solder these 2 jumper wires onto the PCB. Yeah, and make sure to use 2 different colors for the wires that can be easily recognized as plus and minus. So in this case, the darker wire, the brown one, is the negative minus wire, and the red one is the plus one for the signal. These 3 pins here are the pins of the horizontal potentiometer. This one here is the supply pin with 3.4 volts. This one here is the signal pin, and the rightmost, the 3rd one, is the ground pin. So this is what I refer to as pin 1, this is pin 2, and this is pin 3. And our goal is to have the capacitor plus leg to pin 2 and the ground leg to pin 3. So first we solder the darker wire, here it's brown, to the 3rd pin, the negative pin. And we do this by holding the soldering iron to pin 3 until the solder goes all liquid. And then we hold the wire to it, and then until there's good contact. Then we solder the red wire to pin 2, the signal pin. Actually, there's a bit too little solder at this pin, I think. So we'll put some additional solder here first. Alright. Okay, good. Now we won't need our soldering iron anymore, so we can turn the station off. Good. Now we make sure that the connection is sturdy against mechanical stress with a bit of hot glue. Make sure the glue covers both the solder points and the first couple millimeters of the wires and goes down all the way to the PCB so that the wires are fixed together with the PCB, making sure that there won't be that pulling on these wires won't break the electrical contact. Good. Now we can also turn off the hot glue gun, because that's all we needed from it. And now we can take the rail again, push the digital shoulder button pads in again. And then we press it on its place again. Do so a bit firmly so that none of the glue creates a gap between the rail and the PCB. Alright, now we also put the rumble motor in again. This is important. We need this metal bar here to point upwards, not downwards. If it points downwards, you will not be able to put your controller together properly, because there will be a gap within the controller. Finally, we put in the capacitor. Here is our ceramic capacitor, and we just slide its legs into the female jumper wires. Here I'm using a 1 microfarad ceramic capacitor, which always eliminates all of the snapback, regardless of controller condition. On some controllers you can use smaller capacitors with 100 to 700 nanofarad, but I don't recommend doing that unless you have an oscilloscope to measure snapback accurately. Because this is a ceramic capacitor, it does not matter which leg goes into which cable. If you're using electrolytic capacitors, which look like this, instead you need to put the negative leg, which is shorter and has this gray stripe on its side, into the negative cable, the brown here. And its positive pin into the plus cable, the red one here. If you insert them with wrong polarity instead, they will break after only a few hours of usage, so pay attention. Inserting an electrolytic capacitor with the wrong polarity will not only break the capacitor, but also cause it to do misinputs where it will respond slowly and maybe not dash but only walk. So yeah, it's really important that if you use an electrolytic capacitor, that you put it in with the correct orientation. Once more, that means that the longer leg without the gray stripe goes into the red wire that is connected to pin 2, the middle one, and the shorter wire with the gray stripe is connected to the brown wire here, which is connected to pin 3, the ground one. And another important thing is that these wires that I will link into the video description together with the capacitors for the cheapest deal I know on AliExpress, that they have these small spots here with the holes where you can see the metal holders inside. Maybe at a certain angle You will be able to see this on the camera. And sometimes they are a bit loose, and you get the feeling that just from shaking the controller, the capacitor might slide out of its female wires. And luckily, with access to these pins here, we can just use a small flathead screwdriver to push these pins in to make the connection more tighter and more lasting, so that they certainly won't fall out. Yeah, after that, you just what I usually do is I put the capacitor below these wires of the digital L button, so that it kind of is held into place. Then all that's left to do is to put the back shell on again, making sure that the analog sliders here are at the correct position and not like this, for example, because if you do it like this, then this pin here won't have the pin here in its middle, and you won't be able to use the L and R triggers correctly. So make sure that they are pushed almost all the way up, maybe 1 or 2 millimeters below the maximum upwards position when you put the back shell on again. You can check whether you have them at the correct position by just pressing the triggers, and if you get the full range and the click, then you did it right. Yeah, so all that's left to do is to put the screws in again, and then you're done. You now have a controller that will do directional inputs always into the intended direction. Thank you for watching, and good luck with doing this mod on your own. I hope this video will be good enough for you to do everything correctly.